In this lesson, we'll be reviewing relative frequency and probability again, and we'll use our worksheet from Wednesday's lesson as our review. So in our problem here, we're given a deck of 52 cards, and they're showing the seasons of the year. There's 13 cards for each season, and we're randomly selecting a card from the deck 100 times. After each selection, it was recorded in the table, and this table here shows spring, summer, fall, and winter, and the observed frequency for each of those seasons being selected. To determine our relative frequency for each season, we are going to take the number of times we observed it happen over the total. So spring was selected 23 out of 100 times. As a decimal, that would be 23 hundredths, and as a percent, that is 23%. Summer was 34 out of 100, so 34 divided by 100 gives us 34 hundredths, or 34%. Fall was 19 out of 100, which is 19 hundredths, or 19%. And then winter was 24 out of 100, which is 24 hundredths, or 24%. So once we have our relative frequencies shown, we could use the observed frequency numbers and our relative frequency to look at our experimental probability. And in experimental probability, this is the number of times something occurred, or our favorable event occurred, over total times the experiment was run. So in this case, the experiment was done 100 times, and the question says, what is the experimental probability of selecting a card with a summer scene? We see that that was 34 out of 100. If we want to put this as a fraction here, or as a ratio, we could reduce it to 17/50ths. Again, as a decimal, that's 34 hundredths, and as a percent, 34%. Theoretically speaking, our chances of selecting a summer scene would have been 13 out of 52. There were 52 total cards, and there were 13 that were summer. If we reduce that, that is 1 out of 4. So we had a 1 out of 4 chance, theoretically speaking, of selecting a summer scene, which is 25 hundredths, or 25%. For question D, it says now that spring and summer cards had a red background and fall and winter had a black background. We want to find the experimental probability of selecting a card with a black background. So if we're looking at a card with a black background, that occurred 19 and 24 times. So if we combine 19 and 24, and that would be over the 100 total times we ran the experiment, 19 plus 24 gives us 43 out of 100. So the experimental probability of selecting a card with a black background is 43 hundredths, or 43 out of 100. We could write that as 43 hundredths as a decimal, or we could say it's a 43% chance of selecting a card with a black background. Then we're looking for the theoretical probability of selecting a card with a red background. So if we look at summer and spring, there's 13 summer cards, 13 spring cards, so that is a total of 26 out of 52, which reduces to a half. We could write that as 5/10, or we could say theoretically you would have a 50% chance of selecting a red background card. For the next part of the worksheet, we were given a histogram, and it shows a car dealership that has sold 75 new cars this year. The histogram below shows the frequencies for the cars sold at different prices. So this is price per thousand. So this 20 here represents 20,000. This is 22,000, 24, 26, 38, and 30,000. So if we look at each section here, there was a total of 75 cars sold, and we are looking for the relative frequency of cars sold for at least 26,000 but less than 28,000. So that would be this section right here, 26 to 28. There are 12 of those cards that were sold. So looking for the relative frequency, we observe 12 being sold at that range, and that is over a total of 75. So we have 12 75ths. When we divide 12 by 75, we get 16 hundredths. It says to give our answer as a percent, so we're going to multiply this by 100 or move 2 to the right. So the relative frequency of cars sold for at least 26,000 but less than 28,000 was 16%. Next, we wanted to find the relative frequency of cars that are sold for at least 20,000 but less than 24,000. So if we look at least 20,000, that's from here up to here, and there's 24 and 15. So if we combine 24 and 15, that gives us 39 over the 75 cars that were sold. When we divide this, 39 divided by 75 leaves us with 52 hundredths. We want to again write that as a percent, so that is equivalent to 52%. Then our last one was to find the probability that the next card, or what is the probability that the next car will be sold for at least 28,000 but less than 30,000. And based off of our 75 cars, there was only 3 that were sold. So 3 out of 75 leaves us with 4 hundredths. So we could say the chances that the next car being sold will be sold for at least 28,000 but less than 30,000 is a 4% chance of occurring.